Oh, hello, another video, this time a little bit different. It's not CB, it's something else I've been repairing. I've been repairing a pat tester. I don't know whether you're familiar with a pat tester. It's all to do with health and safety. That electrical items are supposed to be tested now in a certain way. In business premises, in hotels, anywhere where the public's likely to come across them or use them, electrical items are now supposed to be tested for safety. And most of the testing comprises of a visual inspection, most of it. But there's also some fancy test equipment which you're supposed to use as well. And that gets quite complicated because then the test equipment is supposed to be tested. And that is what I got. I bought one of these pat testers. I've had loads of them over the years, and I've just got another one. And this one, the pat tester failed its pat test. It failed its safety test itself, because the 13 amp socket that you have on these things, which you're supposed to plug your appliances in to test, was loose. This is one of the sockets, and like many modern things, it's not screwed in, it's held in with plastic clips. So this clips into this. Push it in until it snaps in tight and it clips in, and that's in it. It does hold very good. But this outer framework that it goes in, that went in the pat tester, it's got these thin little flimsy plastic clips. And one of these had failed. As plastic goes a bit funny and loses its strength or whatever, one of these clips had failed. As a result, the socket was not solid on the device. You could move it around slightly. When you pulled the plug out, it lifted a little bit in one corner. So it failed its safety test. The actual safety tester failed its safety test. And as a result, I was able to snap it up. Putting one of these in, replacing this was such a trivial item. These are about £1 each, these frames. But the whole machine, which costs an arm and a leg, was thrown on the scrap heap for a £1 part. So I put a new one of these frames in, and at the same time I replaced the 13 amp socket. So now I've got a working pat tester. I'm going to test my own equipment now to see if I'm safe. And what we're going to try is the old trusty soldering iron. Now this soldering iron I've had since the year dot. I used it in the 80s doing CB repairs. Later on I got a much smaller, lighter one for the electronics, but this was my original, worked off the mains. And because we're going back now to the 1980s, this wouldn't really pass 100%. First of all, you're supposed to do a visual inspection. Just pick it up, examine it, see that the lead has got no breaks, frays, and it's firm in the cord grip all the way along it. It's only a short lead anyway, so we can see it. Make sure it's firm in the cord grip at this end. So that's good. But then we come to the 13 amp plug. Now modern 13 amp plugs have got plastic shrouding on part of them, and when this was made in the 80s, 40-50 years ago, that feature hadn't come out. They didn't have the plastic shrouding. So this one is just the brass pins. Straight away the pat tester would look at this and, oh, don't know, more than my job's worth to pass this one. Oh, I don't know, you know. Well, actually, it's not a failure, it's a warning. You should warn the person that's got it that this is no longer current as far as safety measures, and advise them to change it as soon as possible. They don't have to, you wouldn't fail it, but they advise them that really you should look at changing this. So that's the first thing. Now the next thing we've got to do is check the fuse in it. To see if it's got the right value fuse. I thought I was going to struggle to unscrew this then, but it's quite loose. Right. Oh dear, oh dear, oh dear. That Ken Williams has been at this. So this is another failure. Because this soldering iron doesn't use much current at all, and me being an electronics guy, I put the lowest fuse in it that I consider safe to use. And so because this doesn't use much current, I put a 1 amp fuse in it. And that 1 amp fuse has been in it for a long, long time. But rules and regulations more than my job's worth, mister. That is a failure. Now you won't believe this. This is absolute lunacy. But with pack testing, you've got to put in a 13 amp fuse, an 8 amp fuse, is it 13, 8, 3, and that's it. Or is it a 5? I forget now. But the lowest you can put in is a 3 amp. You don't use anything smaller than a 3 amp. In the pack testing world, fuses smaller than 3 amps don't exist. But so they straight away take this very safe 1 amp fuse out, throw it away, and replace it with a 3 amp fuse. So instead of a fuse that will blow at 1 amp, which is about 250 watts, we're going to put in a 750 watt fuse for a lousy soldering iron that I think is a 25 watt iron. So 25 watt iron, I've got a 250 watt fuse, which is 10 times bigger than you need anyway. But no, pack testing, failure. That's got to be replaced with a 3 amp fuse. Well, I'm sorry pack testers, but I'm not doing it. I put a 1 amp fuse in and it works fine. So there. So already we've got an item which is not safe. It's not safe because the fuse is too safe. This doesn't make sense to me. I mean, it's a soapbox, it doesn't make sense. Right, so let's try it now with the pack testing box. I'll have to switch it on. Just come over to the camera. Here we have the pack testing device. So what we're supposed to do is plug the item that we're going to test into the socket on the box, on the machine. Right, that's the new socket. It's nice and firm. Now if the item has got any metal parts, you're supposed to test to make sure that it's earthed. There's no power on this, so it's not going to get hot, don't worry. But we've got to make sure that this metal part is not going to become live. So you put a probe on it with this tester. Different testers have different kinds of probes, but there we are. Good old crocodile clip on it. So now we can proceed with the tests with the machine. And the first thing we do is, the first test, it says fuse. So I'm going to have to move myself a little bit so I can see it. Press this function and it will test for fuse. It tests for continuity and polarity. So it says a fuse test, but it doesn't know how many amps a fuse is, it just does a test for polarity. And it's happy, okay. So that's good. The next test we want to do is to make sure that the insulation is good, that we've got no leakages between the positive and negative wires causing leakage to earth in this device. So press that insulation test. And now it will test the insulation by putting a high voltage. In this case it's putting 500 volts down the device. But it links the positive and negative wires together so it won't damage the equipment. And it's saying that the insulation is better than 300 megohms. So that is absolutely tremendous. Better than 300 megohms. And then the next test we're supposed to do is the earth bond. And again, the value of fuse comes into this to a certain extent. If it's IT equipment, delicate equipment, we can do that, and it only puts 100 milliamps down the device, down the earth wires, and it's checking to see what the insulation is, and it's saying it's 0.12 of an ohm. So from the earth pin of the 13 amp socket here, right down to the device, then back from the metal of the device, through that crop clip, and back to the tester, it says it's 0.12 of an ohm, and that is a pass. It's got to be less than 0.25 of an ohm. But we can do this at various currents. See, if we press this one, we can bang 5 amps down it, and we put 5 amps down it. Again, it's going down the earth lead, and 5 amps going down the earth lead, and it says 0.12 of an ohm. So we know it's safe then. If something goes wrong and it has an electrical fault, it's going to short out to ground. We can put 8 amps through it. I can do this. You wouldn't put these high current delicate equipment. There we are. 0.1 of an ohm. We can even go crazy and put 25 amps. Here we go. 25 amps. 26 amps it says, is it? Yeah. Yeah. Testing 26 amps. Result 0.09 of an ohm. So there we are. It tests all the tests that there are. So the actual metal of this device is well and truly earthed at less than the test value. It's got to be, with the rules and regulations, it's got to be less than 0.25 of an ohm to ground this the metal of any object that's got metal on it, so it's say a toaster or whatever. So there we are. So it's passed its electrical tests. The insulation is good. The earthing is good. So we can now put a sticker on that to say it's passed. Although it hasn't really, because we've got a 1 amp fuse in it, and that is extremely naughty. It shouldn't be a 1 amp fuse that will blow at 1 amp. It should be a 3 amp fuse. Now, if anybody anywhere can tell me a sensible reason why you replace a 1 amp fuse with a 3 amp fuse just because some idiot plonker in some office somewhere has decided that that is the electrical regulation, I'd love to know the answer. But just absolute, well, what can you say? But that's it, a little demonstration of something I've been messing around with, a pat tester. It's in absolute mint condition. There's not a mark on it. The only mark on it was some slight scuffing with the 13 amp socket plugging in and out. But when I replaced the frame, to do a good job of it, I replaced the 13 amp socket as well. So it's absolutely mint. And now I've got to decide what to do with it. Oh, well, it was a bargain. Thanks for watching.